Hello, my name is Matthew Dalton. I am pursuing an engineering management degree from Purdue University. This presentation will present how previous capital expansion projects could have been benefited from using decision tools. In a previous position of my career, I was tasked with leading a project to expand our production capacity for a bottleneck operation. The status quo equipment was supplied by supplier W and met the basic needs of our production. However, as the technology of the facility was increasing, there was a desire to purchase new equipment that could be connected to an integrated factory system for more data tracking and increased knowledge on the daily issues of production. Supplier W can handle this request, but there are some overall limitations that the supplier is not willing to change within the scope of the project. With this new project, the team has decided to also review equipment from supplier Q to see if their application may fit the targets of the project. Review of the decision tools and the results of the analysis, the team has decided to proceed with supplier Q. The following slides will present the data that the team built and used to lead to this decision and the risk that the team has agreed to absorb. The chart here shows some of the critical values that were used to make this decision. Supplier Q provides a lower cost machine, a much higher support ability, scored a higher expected value, but neither option showed a dominance when reviewing risk. This highlights that this decision is not an easy one to make, but with the use of tools and expert calculations, an educated decision can be found. First, the team got together and decided to build an influence diagram to model the decision that was in front of them. Starting with the end goal of meeting our performance targets and the decision to choose between supplier W and supplier Q, next, the team decided to find the influences that would impact these decisions. Obviously, the cost and lead time are measurable variables of the project and can be found within the basic quoting process. Then the team highlighted support availability and operator interface as important features to review on each supplier's proposal. Finally, the team highlighted the automation design as being critical to the project, and knowing that there were different levels that needed to be reviewed, solicited the help of some experts to try to build the inputs of the automation design. The team took the influence diagram and created a matrix. The weights were agreed to as a team from most important, the automation design, to least important, the lead time. Then the values were filled in for each supplier. Their cost and lead time from the proposals, the operator interface and support availability were judged and scored based on review of each supplier. Then finally, the experts provided some scores for the automation design and provided some probabilities based on their expertise. The current supplier W has a high likelihood of overall meeting the targets, but also based on our knowledge could score low if we cannot find a solution for the project goals. The new supplier Q is 50-50 if they will supply a high or low scoring solution. The experts reviewed the supplier and generated those potential high and low scores for the new supplier. At a minimum, the target to create a connected facility can be met, but there are other challenges that were found during the review. The team brought the matrix and the influence diagram together and built out this decision tree. They brought in the attributes and showed them to the right of each of the branches of the tree, along with the weights for each of those attributes. For the cost, supplier W was scored a 50 because they met the initial target of the project, and supplier Q was scored a 75 due to the fact that they were slightly higher. Then for lead time, again, supplier W was scored as a 50 because they met the target of the project, and the 70 for supplier Q was calculated out of a comparison. From there, the team will take these values and solve the tree. Then the team solved the tree to find the expected value of this decision. To complete this, we took the weight and multiplied it out across each attribute, and then summed and normalized the results for each branch of the tree. Those are the cumulative weighted scores shown. With that, the team used the probabilities supplied by the experts to find the expected value for each supplier And those final values were 57.67 for supplier W and 64 for supplier Q. The higher scores of supplier Q look to be traceable back to the cost and support availability. The team then agreed that with this higher score and the much higher support availability, that supplier Q might be the right choice, knowing that there is support for startup very close, and they are willing to help us succeed in our project goals.